Hey everyone, so before we continue, we need to understand a probability concept called portfolio expected return. And this is a rather intuitive concept, it's not hard to understand. All we're doing is we're taking the weighted average of the expected returns of the assets in our portfolio. So what do I mean by that? We find the weight of the asset in our portfolio multiplied by the expected return of that particular asset. And we then add that to the next weighting of the next asset times its expected return, and so on and so forth. So let's see if we can actually calculate this. All we're going to do is first we need to create a new data frame here, and we're going to take our original data frame called pivoted, and we're going to resample this. And the reason why is we're going to resample, we want annual values. And right now we have daily values. We'd like to get annual values. And so what we're going to do is we're going to take the last value in this data series. So I'll output this so you can take a look at what I'm showing here. So there you go. So if you look, we have these annual values here, and we've taken December 31st, the last day in these annual values. Now what we're going to do is we're going to apply a percent change function on top of that. And there we go. Now we have annual returns on this data. So now we can actually calculate our expected return, our annual expected return. And so to do that, all we're going to do is just take our df dot mean. And there we go. And so all we've done was actually very easily, we just took these annual returns and we found the mean. So before I go any further, we need to talk about expected return and how it's used, because it can be used in two ways, both a historical context and a forward-making forecast context. And usually in the past, when we're looking at history, we are finding the mean or the average. And you may ask, why are we doing that? Well, if we were to pick randomly out of the past, let's say we had 10 values and we had to randomly pick a value out of that, and guess what would be the closest value? Well, the closest value we would get would probably be the mean. Going forward though, when we're making a forecast, we use the probability weighted average, because in the past we used a equal weighting average. So 1 divided by n. Going forward, we may have different probability weightings, and that is based on different unconditional and conditional probabilities. In this sense, we're going to use the past as our expectation of the future. And a lot of times we do that. So now we've calculated our mean. So we're using this past here, this equal weighting of this average. Now that we have that, we're actually just going to call this df.mean. What we're going to do now is we're going to create some weights. And we're going to say a 0.75 weighting for Apple and a 0.25 weighting for Nike. And so what we're going to do now is, actually we're going to say this is expected return is equal to this. Just output that. And now what we have our weights, we have our expected returns, and we're just going to multiply them together. So we're going to take ER times W. And now we have these two terms here. We would just need to sum them together. So to do that, I'm going to say that, put that here, that's sum. Now there's an easier way to do this. We can actually use NumPy, so np dot, and we can put in our weights and our expected return. And we'll get the same value, and we do. So I hope this was helpful. This is going to be helpful in our next video, where we're going to have to use this exact process. So if you like this video, please subscribe. And until next time, thank you.